In example 3.3.3, we're looking at a research study done where they think that drinking tea might enhance production in interferon gamma, which is something that helps the immune system. So a study was done where there were 21 people who don't normally drink tea or coffee, and they did a random experiment where they split them into two groups. 11 were randomly assigned to drink tea, and the other were assigned to drink coffee. After 2 weeks, they had blood samples taken and measured their interferon gamma levels. The data set are obtained in StatKey and ImmuneT. So we're asked first, what's the quantity we're interested in this study? And to write it with proper notation, is it a parameter or a statistic? We are using a sample of people, but we're really interested in the entire population, comparing these groups. And if we're thinking of looking at levels of interferon gamma, that's going to be quantitative data. So we're interested in comparing the means for these two groups. And so how we would write that using proper notation is we're interested in the difference in the population means. You could either write like group 1 and group 2, or I'm going to use T and C for tea and coffee. So this here is the difference in the population mean interferon gamma levels for T here equaling the tea group and C equaling the coffee group. This is considered a parameter because it is a population value. On the next page then, we have some more parts to this problem where we're going to look at some more details. So in the first part, we're asked, how could we create a bootstrap distribution to estimate the standard error? So when we're doing bootstrapping and we're comparing two different groups, the idea is that we're going to take and resample with replacement bootstrap samples from each of the groups. And each time we do that, we're going to compare their means. So the idea here is to resample with replacement for the 11 T values. And then separately, we bootstrap or resample with replacement from the 10 coffee values. So what we'll have then is two different sets of values, a set of 11 and a set of 10. From each of those, we're going to compute the mean. So we'll compute the sample mean for the T values, the sample mean for the coffee values, and we'll look at that difference. We'll do this process then a large number of times, and we will plot that large number of xt minus xt values. And that will build up our bootstrap distribution to allow us to look at our confidence interval. So we're going to go to StatKey and generate the bootstrap distribution. We're asked for what's the point estimate for the original sample and what do we estimate as the standard error by doing our simulation. So if we go to StatKey, we have the middle column here for bootstrap confidence intervals, and we select the one we're working on, which is difference in means. And then this data set's built in, and if it's not a data set that's built in, you can edit the data and put your own data in here. So we want to find the ImmuneT data. So if we look in the upper corner under the original sample, it shows us that for the T group, we have the 34.818. For the coffee group, we have the 17.7. The difference in those two means is 17.12. So that's our statistic for our original sample of tea minus coffee. Then if we generate bootstrap samples, generate 1,000 samples, what we can see in the upper corner of the simulation of the bootstrap samples is that the standard error is 7.762. So we'll go back here to our example problem and write down the info we found from the original sample. The difference in the two values was 17.12. And then our SE, or standard error, based on our 1,000 samples, was the value of 7.762.